So to find out if these are arithmetic, geometric, or neither, you want to find out if there's a common difference or a common ratio or neither. So you'd want to think about the common difference that goes with the arithmetic, the common ratio R goes with the geometric, and then I'll just put the word neither for neither. So then here on the first one on the left, we'll start looking for a common difference first. We want at least a few terms. Let's go ahead and find at least 4. So if you find the first one, this is where instead of n, you're putting a 1 there. So then on the other side as well, you'd have a 1 there where the n was. Then you subtract 3. This is -2. So this is a1. This is the first term. Then you go further. You put a 2 there where the n is. We're just starting over, basically. So you put a 2 there where the n is. And you got 2 minus 3. Then you got -1. And then we're starting over for a3. You put a 3 where the n is, so now you have 3 minus 3. This is 0. And then that's normally enough, but let's go and find one more. So here's a4. And you put a 4 where the n is, just starting over again. Subtract 3, and this is 1. So what you're doing is you're taking a term. You'll start with a2. This -1, which is the a2, it will go here. And you'll subtract a1 from that. So it'll be minus -2. And this becomes +2, which means 1. And so now you can check more. You can check the third term minus the second term. The third term was 0, so that would go here. The second term was -1, that'll go there. And then this will resolve into +1, and you add that with 0, and you got 1 again. So far we have the same number here. And you can go further, where you take the fourth term and you subtract the third term from it. The fourth term is the 1, and the third term was the 0. You substitute them in, and you got 1. So here we have a common difference. That's enough to know that this first one is arithmetic, because it has a common difference. We don't have to check. It's definitely not going to be neither, because it's one of them, and it won't have a common ratio. Now here, this one, you can just go through the normal process. So first you find a1 using this formula. You leave the 1/2 the same, but for n, you put 1. And this would just be 1/2. So this is the first term. Then you go on to the second term. You just start over again. And it's important that this is in parentheses, because when you raise these to the second power, you're raising both numbers. The 1 is being squared, and the 2 is also being squared. So you can write it separately like this and split them up. Here, 1 squared is 1, 2 squared is 4. That's as simplified as it can be, so a2 won't simplify further, so we're done with that one. And you go on to a3. And you start over again. You put the 3 where the n is, then you apply it to both numbers in the fraction. This is 1/8. It won't simplify beyond that, so that's as far as we need to go there. and then you start over. We have 1/2 to the 4th power. You apply the 4 to both the 1 and the 2. This will now be 1 on the top. On the bottom, that will be 16. So we have our terms. These are the 4 terms. If you think it's going to be geometric, you can just start checking for that right away. Or if you want, you can go through the arithmetic process. Normally you start with the arithmetic, then the geometric. So if you want, you'd be looking for a common difference. You'd say, in this case, it's A2 minus A1. This is what A2 is, and then this is what A1 is. Checking here will end up with fractions, so you'd have 1/4 minus 1/2. We need to get common denominators. We have to change the second fraction by multiplying the 2 by 2, and you end up multiplying the 1 by 2 as well. That turns into 2/4, and we have a common denominator. So this ends up being -1/4. Then you check another pair. We'll check A3 minus A2 now. Here's A3, it's the 1/8. A2 is the 1/4. So you have 1/8 minus 1/4, but we need a common denominator again. So you multiply the 4 by 2 and the 1 by 2 as well. What you do on the bottom, you have to do to the top of the fraction when you get common denominators. Once you get the common denominators, you got 2/8. So this will be -1/8. Since these aren't exactly the same, it's not the case where there's a common difference. So it's definitely not arithmetic. We don't have to redo the first part where we found the 4 terms. This will be the same, no matter if you're checking for arithmetic or geometric. So now, because it's not arithmetic, we'll go and check if it's geometric. You find R by saying A2 divided by A1. So it's a term divided by the one right before it. If you want, because these are all fractions, you can even write it sideways. So normally we want to think about it like this when it's integers, but when it's fractions, you can say you have A2 divided by A1. This is one way to do it. And so A2 is the 1/4, A1 is the 1/2. Here you would keep change flip. You keep this one the same. You change the sign to multiplication and you flip the second fraction. Then you can multiply across. 1 times 2 is 2, 4 times 1 is 4. This reduces. Both of these can be divided by 2. So this will simplify to 1/2. And then you check another pair of numbers. You start with A3 and you divide it by A2. A3 is the 1/8 and A2 is the 1/4. And you keep change and flip this. So you keep the first one the same, change the second sign, change the sign to multiplication and flip the second fraction. Then you multiply straight across, 1 times 4 and 8 times 1. So this will be 4/8. This is 1/2. Or if you want, you can say that both of these numbers can be divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So far we have the exact same ratio. We can go further and check A4 divided by A3. This one is A4 and this one is A3. So you say 1/16 divided by 1/8. Then you keep change flip. Keep the first fraction the same, change the sign to multiplication, flip the second fraction, and multiply straight across. The numerators multiply, turn into 8. The denominator will be 16. This is also 1/2. Both of these can be divided by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. We have the exact same r. So it was the exact same r all 3 times. This is the case where we have a common ratio. So this one is geometric. Now here, you do the same thing. You find the first 4 terms. Wherever you have n, you just put a 1 for the first term. This becomes 1 minus 3, which is negative 2. Then you start over. You put the 2 where the n is, and you simplify it. This becomes 8 minus 3, which is 5. And we'll find another term. You start over here. You put the 3 where the n is. This is 27 minus 3, which is 24. Then you start over. You start over to find the 4th term. You put the 4 where the n is. This is 64 minus 3. Now we have our 4 terms. So first we'll look to see if there's a common difference. For the common difference, you'll take the second term and subtract the first term from it. The second term is the 5, so that will go here. And the first term is the negative 2, so that'll go there. This will simplify into 5 plus 2, which is 7. Then you move on. You take A3 and you subtract A2 from it. We see that A3 is the 24 that we found. A2 is the 5. Substitute these in. This is 24 minus 5. Here, this is 19. These are not the same. They have to be the exact same for there to be a common difference. As soon as you see that these aren't the same, we know it's not arithmetic. At this point, you go on to check if it's geometric. So for the geometric, because they're integers, you can say that it's A2 divided by A1, and you can set it up as a fraction. If you want, you could always do it the way we saw the other ones. This is more helpful when it's a fraction, because of the keep, change, flip. Whereas this is more helpful when we have integers. But you can do it either way. Now here, A2 is the 5, and then A1, that's the negative 2. So you say you have 5 over negative 2. And you can leave it like that, or you can move the negative sign outside and say it's negative 5 halves. Then you check A3 divided by A2. A3 is the 24, that'll go on the top. A2 is the 5, that'll go on the bottom. So you got 24 divided by 5. As soon as you see that these are not the same, we also know that there's no common ratio. They have to be the exact same for there to be a common ratio. So it wasn't arithmetic and it wasn't geometric either. That means that this is the case where this was neither. And that's how you can figure out these ones. So you're just trying to find out if there's a common difference. If there is, then it's arithmetic. Or if there's no common difference, and you check if there's a common ratio, and there is, then it's geometric. But if there's no common difference and there's no common ratio, then it's neither.